Good afternoon, everybody. Thanks for holding out till the last few talks. I hope you're all excited to get into the hacky stuff, but I want to start off by telling you a story. And I want you to meet Axel. Axel is a senior Android developer at a completely fictional company named Run for Roses. And it's a Friday afternoon, and his product manager is quickly asking him to implement something. They have this big partnership coming up with a wedding app, and they want that you can order flowers through Run for Roses directly from this wedding app. And those apps need to communicate. So you have this Run for Roses app that Axel is developing, and now this kind of wedding planner app needs to interact with it. And okay, Axel, it's late. He's thinking, okay, I can make this work quickly. It's just handling an intent, right? So, okay, the wedding planner should send an intent to the Run for Roses app. The Run for Roses app has some kind of intent handler, handling those intents from the wedding planner app, and then forwarding them to the right activities, such as Roses for Weddings, which is probably the most applicable one for the wedding planner app. But hey, it's even extendable to all kinds of partner apps. Fabulous. So then we meet the second person in our story. That person is named Slash. It's a bored student in his mother's basement, and he's basically getting off on finding out mistakes from very big companies. And he hears his mother raving about this fancy new wedding planner app. And of course, what does a bored guy do? He goes and breaks it. So next day in the newspaper, we see, thanks for the flowers, popular delivery app Run for Roses racking up your user's phone bill. And it seems like a very big disconnect. But these kind of very weird disconnects happen all the time. And this is not because Axel was a very stupid developer. These things are happening all the time. And you could very well say that people like Slash have quite an appetite for destruction. So in the coming half an hour, I want to take you through a few of these scenarios, explain you what is happening and what you can do about them. So I want to welcome you to the jungle that is mobile application security. And why me? Well, I'm a team lead at GuardSquare, and at GuardSquare, we're specializing in mobile application security. We're basically trying to make the world a safer place, especially the mobile world. So you might know us already. Our most famous thing is ProGuard. ProGuard is no security product, but it's a product aimed at optimizing and shrinking apps. Then we have our current flagship products, DexGuard and XGuard, for Android and iOS each. And they are really code hardening products. So they are aimed at delaying the work of reverse engineers. They make it harder for a reverse engineer to see what is happening in an app. So let's get back to this case of Axel. Axel has this Run for Roses app, and he clearly had a mistake. So could a code hardening solution have helped him? Well, in my opinion, maybe, but there was a security issue. Code hardening isn't meant to hide security issues in the workings of your app. Code hardening is meant to protect your IP. Code hardening is meant to make sure that people don't do stuff with the app that they shouldn't, but not to hide your security issues. So to me, trying to use code hardening to prevent this kind of stuff from occurring, it's hiding an elephant behind the tree. It's harder to see the elephant, but you might want to consider removing the elephant from your app. Don't let security be the elephant in the room if you're developing an app. And now you're thinking, okay, Axel was probably really stupid. I'm a smarter person. I would catch these things in a pull request. If you're thinking this, I have quite bad news for you, because just in the recent years, there's been intent abuse on Samsung Flow. With OwnCloud, it was possible to steal protected files on Android. There's multiple bugs that lead to remote code execution on TikTok. There's issues on Grab, on Twitter, on Dropbox, on New Relic, on Coinbase, so probably in your app as well. So don't think that you're smarter than any of these guys. There's so many ways that people look at those things. And what's worse, they always make it seem so easy to break everything that is out there. So what are they actually doing? What is an attacker looking at? Well, there's a very simple answer to that. Everything. And of course, that's probably not detailed enough for you guys, so I'm trying to break it down, and then I get to like quite an infinite list. There's insecure cryptographic algorithms, there's wrong hostname verifiers, there's unencrypted credentials, there's unprotected native code, there's capability leaks. It's quite an endless list. But that's not how an attacker goes about it. It doesn't go like top down through a list of what could it be. He starts poking around. So what does an attacker do when it starts looking for a concrete mobile app vulnerability? Well, there's a few ways to go about this. The first one is, for instance, to do static analysis of the APK. Basically, that's just, let's download the APK from the Play Store again, and let's poke it. Let's see what we can get out of it. A very common way to start this is just put it in a decompiler. A very well-known one is JDAX. It's open source, it's on GitHub. I recommend you have a look if you don't know it. But basically, you just open your APK, and you can see quite a lot of things happening in your APK just by opening it in such an open source tool. Other ways you could go about this is, for instance, to try to intercept network communication. A lot of apps communicate to some backend, and if you don't secure your network communication properly, it's probably easy to man in the middle of the thing, and in that way, you can discover a lot about the app by just looking at the traffic. Or maybe looking at app-to-app communication. In the case of the intents, that's also a very interesting point. Attackers know, like, these are interesting entry points into an app. In this situation, though, Slash used just basic static analysis. So he went into JDAX, and he went looking for the app-to-app communication via a static way. And he discovered this piece of code. In this piece of code, the wedding planner app makes some start rose order intent and piggyback some extra string referring to roses for weddings. And at that point, our Slash is thinking, okay, we see an intent. How can I abuse this? Because that's basically the only mantra that an attacker has. I see something, how can I abuse this? So an intent is basically, like an intent handler is basically registering to the Android system for events, and it gets notified when this event occurs. So how can we abuse this? Well, try to maliciously craft an event. What kind of events should I craft? Well, let's have a look then at the actual Run for Roses app. So same thing all over again. We take the Run for Roses app, we dump it into JDAX, we see this piece of code. Of course, it takes a bit of scrolling to find the right piece of code, but it's all there for the taking. And there you see that this string, which was piggybacked on the Run for Roses app, goes directly into a class for name. So basically, we're allowing any user of on the phone, any other app, to directly call into a random class in my own app. So that's probably where things can go wrong. Because basically, if I have permission to do something, another app can ask me to do that instead. So this is what Axel was thinking, what is happening. But Slash has discovered, well, there's an unintended link there. I can do more with this intent handler class than I thought. And just so this one simple thing leads into big trouble. And this is also not theoretical again. So let's have a deeper look at the Samsung Flow app. Samsung Flow is basically an app that allows you to control most of what your phone can do from your computer. You can imagine that's an app who allows you to control most of the stuff remotely, has quite a few permissions. So you hear me coming already. If you can abuse this, the sky's the limit. So actually, You put Samsung Flow into JDEX, you find something very similar. You find this getString extra and class for name getString extra. There's some stuff in between, but it's pretty much the exact same setup. It's not stuff we found out. This is a publicly known CVE from last February, but these are real-world cases of major companies missing very important things. And so, because Samsung Flow has so many permissions, it's possible to do almost anything on your phone. So, this is an example code of how you could abuse this. You could just create an intent towards the user select Wi-Fi service call from Samsung, and you can broadcast it, and that allows another app to call a phone number without having calling permissions, just because the Samsung Flow app has these permissions. So something very easy, which is like, I'm just going to make compatibility with another app quickly, turns into a major security leak, having big consequences, calling arbitrary phone numbers, but it didn't end there. You could even factory reset a whole phone from any random app could do that. You could install arbitrary apps and uninstall arbitrary apps. Imagine some random app just replacing your banking app with a malicious one. Could all just happen, just because one guy decided to implement an intent handler. So, of course, we're out to get them. Like, that's our mission, and that's the mission for many people in the industry. So, what did the industry do? Well, if I have to summarize it, I would say they're making acronyms. That's the approach, and I have to say it's been quite effective. But it turns out that sentences like the following is only readable for mobile application security experts. You get something like, the ADA requires compliance to the MAS-VS L1 standard developed by OWASP to get a MASA badge. It is recommended to use the MASTG during testing. I don't know about you, but for me, if I put this into kind of a pull request on my software, I get rejected immediately, like, make stuff clear. So let's make all of you a bit more application security experts. Let's drill down in this. So the basis is OWASP. OWASP is short for the Open Web Application Security Project. This is a very big project. It's all open source out in the world to help people get insights in their security. And the OWASP has a specific section for mobile application security, and they have the MAS-VS. It's a mobile application security verification standard. You can have a look at GitHub. It's all free. It's all open. Very interesting stuff. So what is in there? So there's a couple of different sections. And so there's the MAS-VS L1, short for level 1. And it's basically the basics for everybody. If you're publishing any app, it's a good idea to have a look at the MAS-VS L1, because it's probably good for you that you adhere to these kind of requirements. An example, security controls are never enforced only on the client side, but on the respective remote endpoints. Seems like a very sensible thing to do for everybody. I expect it from every app I use. I expect the security to be as much enforced on the server side as possible. But of course, I might have higher standards from a banking app or a medical data app than I have for my to-do list. So there's a level 2 that is relevant for more apps, like for more apps that have more security needs, have sensitive data. So that's for additional defense in-depth controls. An example here is remote endpoints verify that connecting clients use an up-to-date version of the mobile app. I don't care if I use my mobile app, a mobile to-do list app from a year ago, but I don't want anybody accessing my bank without the latest security updates. The third section of this MAS-VS is the MAS-VS-R, short for resilience, and it's basically about preventing reverse engineering. It's not the next level, because there might be customers who are not interested in L2, but are interested in R. Imagine you're a gaming company. You're not really handling sensitive data, so the L2 might be not as necessary, but you want to prevent cheating. And some cheats you can't prevent on server side. So there, preventing reverse engineering is a very important step for you. If you're a bank, you probably want both L2 and R, because you handle sensitive data, and your IP is very important. So there's different gradations and combinations inside of these categories. So an example of what would be in the resilience category would be the app detects the presence of widely used reverse engineering tools, such as code injection tools, hooking frameworks, and debugging servers. It's pretty important if you want to prevent cheats in a game, for instance. So, okay, now we know the criteria, but how do we make this actionable? How do we test that these criteria are fulfilled? So OWASP also gives us an answer for that. Though how to ensure the MASVS? Well, with another acronym, the MASTG, the Mobile Application Security Testing Guide. And so this is basically a book explaining you how you can test for the MASVS. So are we done? Of course not. We're never done. The next step is, okay, let's make an alliance led by Google, the App Defense Alliance, and they're going to make sure that there's some kind of standardized testing in labs. So you can have a lab do an MASA, a Mobile Application Security Assessment. And they're basically going to check for you whether you are compliant to these MASVS standards. So to summarize this, we have the MASVS, which are the criteria, the MASTG, how to test for the criteria, and then we have these authorized labs saying, okay, you get a badge, you are good to actually have these compliant apps. So are we done? Well, I didn't really touch upon a quite important question. Does it actually do anything? Because now we basically have a bunch of documents telling us, be secure. So let's have a look back at our dear Axel with his Run for Roses. And if we start reading the MASTG, we come here. All inputs from external sources and the user are validated, and if necessary, sanitized. This includes data received via the UI, IPC mechanisms such as intents, custom URLs, and network sources. And there we are right on the money. We see we didn't sanitize our intents. So it is explicitly mentioned in this MSTG. So at least in the case of both Samsung Flow and a Run for Roses thing, the MSTG guide would have helped them. So my question is a bit repetitive. Are we done? Well, I hope some of you will start to read this thing and then discover the next problem. I think if you start reading this and then start testing your app, by the time you're done, many of your apps will be outdated. So 732 pages, that's just the latest version. It's expanding every day. So maybe you don't even keep up. So there is still something missing. This is not Paradise City yet. So we need something else. And so that's where GuardSquare jumps back in. We have our existing product portfolio, but we feel there's a gap here. And we try to fill gaps if we see them. So that's where AppSweep was developed. AppSweep is basically an automated version of the MASTG. Do we cover everything? Of course not. It's too big, but that's where we want to be. And we want it to be as easy as possible. So it's basically just drag and drop your APK, upload your APK or your bundle or even your SDK, and we're automatically going to scan for quite a bit of this whole MASTG guide. And so do we detect a Run for Roses case? Yes, of course. It's imaginary. I can, of course, make something work. So let's use Samsung Flow. If we drop this vulnerable Samsung Flow version in here, you immediately get the issue. You can see external data from string intent get string extra is used for code execution via intent context class. So you can immediately see that we found this through data flow analysis. It's marked as a high vulnerability thing. You immediately get a reference to the MSTG guide. You know in which classes, on which lines, your problems are. If you use a name-obfuscated APK, you just upload your mapping file, and you will get all the information in terms of your own code. You can see the actual line numbers. You can see how we did the control flow. So get all the information right there in one page without needing to do any manual analysis. So we really want to be with you during your whole development process. And we want you to think about all these things. Well, we want you to think about them, but we want you to do about them less yourself and get more in an automated way. So we don't only allow you to upload those APKs or AABs. We have integration in GitHub Actions, into Gradle, into Bitrise. We try to be within, make it as easy as possible for you. And on top of all of this, just like the MASTG, all of App-Sweep is completely free for you to use today. Let me explain a bit more how we see the whole life cycle of your application. Because we try to help you at every stage of your life cycle. The first step, when you're building it, you need to protect your IP. And that's where the code hardening tools come into play, and where you have immediate feedback through a report on what kinds of threats you are protecting from, what kind of improvements you need to make. It's mostly aimed at the MASVSR part. Then comes testing. And we believe testing should include security testing. So that's where App-Sweep fits in. It's a tool that will test your security and see if you actually are not leaving big holes behind. But we also believe that security doesn't stop the moment you ship your app. So as part of an extension of DexGuard and XGuard, we have ThreatCast, where you can monitor what is happening with your app while it is actually deployed. So you know what kind of threats people are making to your app. If somebody tries to hack your app, attack it with Frida or so, you get immediately notified and you get an overview of what is happening over there. So we try to be with you along the whole way of your app development cycle. So let me do the most dangerous feat a person can do on stage, live demos. I'm using not a real app to make sure I'm not shaming any big companies, but we're using something called PIVAA, a purposefully vulnerable Android app. So let me go to App-Sweep. So we have this PIVAA app here, and you can see we keep histories of multiple uploads of the same app, so you can see what happens to your app over time. When do you introduce a new problem? It's not just the one time you need to scan. You need to make sure that over time you're not creating new issues. So if you click open our latest build, you immediately see references to the different severities the issues have, the references to the MASVS violations. We make a difference between your code and your dependencies, because that's usually handled in a pretty fundamentally different way. You can see in what kind of packages your security problems are living, and you have a list of all the issues you have. Whatever issue you put open, you have always a pretty similar kind of view. You see an explanation of the issue, references to the whole OWASP stuff, where in your code it is occurring. You can see decompiled parts of your app, so you can see what it approximately looks like in your source code. Of course, it's not good enough to know you have a problem. You need to know how to fix it. So we always have some recommendations how to fix it. Some of them are easier fixed than others. And we have some external links to read up on more information about these issues. So our goal is really to make it actionable and insightful, and not just to scare you with the amount of issues, because some tools just give you an endless list which you never get to. Our goal is really to make this actionable and as insightful as possible, so as a developer, you actually know what you can do to improve. So let me quickly go back to the slides. So AppSweep is quite a young product for us. We released it about a year ago, and it's still in full-fledged development. So we are still not where we want to be. 732 pages is a lot to cover in an automated tool. So more extensive findings is always on top of our list. We want to expand the amount of stuff we can find. We have some very advanced control flow analysis to find some stuff, but there's always more to do. We're also still limited to static analysis. So on our agenda, it's also to add dynamic analysis to find more other types of attacks than we can currently find. AppSweep is still Android only, and I think that doesn't matter for the most of you here, but iOS support is also on our shortlist to add. But most of all, AppSweep is heading to a place where it can help you the most, and for that we need you. So please, if you use these things, if you find something which is unintuitive to you, if you feel like we are missing something, come talk to us. On this bottom right of AppSweep, there's this button where you can go into a chat thing. It's not a bot. We're not an AI company. We are having real people on the other side to help you further because we want to hear what helps you the most. We want to make it the most that we can. Because it's really all about you guys. And at GuardSquare, every time that we get stuff from others, we try to contribute back to the other side as much as possible. So if we take OWASP, well, we take a lot of OWASP and we try to automate it. But on the other side, we are also noticing security gaps inside of all the OWASP documents. And so we are making pull requests to improve OWASP itself, to extend it with more findings that we see are important to add. So it's a bi-directional link. We're not just trying to leech from the whole OWASP thing. And it goes further. For app developers, we're hoping people try us. But if we do internal testing with more features, it happens that we do responsible disclosures as well. For instance, in 11 cases, we found a totally unprotected backend database. We were able to dump full databases of 11 apps. Totally no credentials at all. So in those cases, we definitely do a responsible disclosure ourselves. We want to get back to you guys if we find stuff ourselves. So that's also where we try to give back people who do the effort of trying us out. Also, we're using a lot of open source stuff. And not all of AppSweep is open source, but definitely the core of AppSweep is the same core as the core of ProGuard, and that is fully open source. So if we develop new code analysis techniques, they are all put in this ProGuard core library, and we give it back to the open source community. And we're excited to see what kind of projects you can come up with for a library that can manipulate and analyze and read and write Java bytecode. So have a look. We're also hoping to get all of you just excited about this project. And if you want to work with us on it, please come and join us and help us build this thing. Because we're always on the lookout for more people to help us with this. But most of all, and if anything, we love safe apps. And please, if you take one thing away, just take your app, upload it, try it. It's 100% free, and give us feedback. You can find the link here. You can also find my email address. So if you have any feedback, please, you can also directly contact me. You can try to find me after the talk. And just GuardSquare is on all social media. So whatever channel you prefer, we'll probably have a way for you to contact us. So I hope together we can make a safer world for the whole mobile application industry. Thank you. I think we have some time for questions.
That's a good talk. I was wondering, is your product that you're offering only doing analysis on an APK, or do you also offer like a lint sort of a tool so that you can do it on a pull request, or you can just do it on a source code rather than on the APK?
We are fully on the APK itself.
Okay.
So the only thing we accept are binaries. Not at the moment, no. It's not planned at the moment to have an offline capability, although we know there's an ask for it. But currently it's a cloud offering. It's a production APK we want, because if you upload a debuggable APK, we will notice this as a security risk. Because debuggable APKs make it way easier even to start reverse engineering.
A question, is there anything preventing me from uploading someone else's app?
No. So I guess if you're very malicious, you could try to use us to find holes in other people's app. Yeah. So if there's any finding, we will try to give you some suggestions how to fix it. So in the case of missing SSL pinning, we will say you did this flag wrong. In the case of debuggability, it's just changing the Android manifest. So we try to be as actionable as possible. In the recommendations box, there should always be something you can take action with as a developer. And if you can't, please contact us so we can change that. Well, we try to raise awareness of security, and at the moment we just hope that will take some traction to our other data strengthening, code hardening products. Some of the issues will refer to, for instance, DexGuard that can help you if you have like API keys in the clear that we can detect. Sometimes you might be pointed to a commercial solution. Most of them will not, but we hope to raise awareness in general. Any other questions? If you don't dare to ask a question, feel free to come up to me afterwards. Thank you very much.